每天起床第一句，先给自己打个气，每次多吃1厘米，都要说声对不起。墨镜墨镜，看看我的锁骨在哪里？美丽，我要美丽，我要变成万人迷。我要变成万人迷。为了变成小蛮腰，偏偏提着一口气。为了穿上比基尼，迟早吃成沙拉鸡。挺身离去难自己，可惜吃什么都不腻。努力，我要努力，我要变成万人迷。卡路里卡路卡路里卡路里卡路卡路里卡路里卡路卡路里卡路里卡路卡路里，我的天敌，燃烧我的卡路里。拜拜，甜甜圈，珍珠奶茶方便面，火锅米饭大盘鸡，拿走拿走别客气。拜拜，咖啡因，戒掉可乐戒油腻，沙发懒懒玩游戏，别再熬夜伤身体。拜拜，红身体。
How to write Sing CSV with both motion control and I/O control. On the screen, the assembly machines. Let's see the script. The script of the assembly machine of mop S1 to S9 triggered by input 1 to input 9. Just coincident, input 1 trigger P1 S1, input 2 triggered P2 .cc, input 9 trigger P9 sequence 9 .cc file. It's just coincident. That means the input 1 not only trigger P1. If the engineer write P2 in this column, P3 whatever's still can be driven by trigger input 1. The P1 is control 1 triggered. The control CS control system is here. These examples, the whole actions is controlled by I/O control. If together I/O control and motion control, how can we write our Sing CSV? Let's use another examples to show how to write the CSV Sing file. The name of Sing, let's choose the KH33 plc.csv. This machine is 2-station, 3-axis water jet cleaning machine. Let's see the script. KH33 plc act.dat input 1 until input 9, still 9 cc file listed here. But in these machines, only 2 control systems. The first one is P1. The second is P2. So in these 9 trigger the files, you can see the first one is P2 CC file, the second is P1 CC file, and the P2 CC file, P1 CC file, etc. So there's no strict relationship, the input 1 and the control system 1. The input 1 can trigger the process control system 2, while in here the input 2 can trigger the process control system 1. The input 9 can trigger control systems CC file control system 2. You can write arbitrary while the P2, P3 is both with 3 motion axis control, but still 1 PLC control. The PLC table like this. The Y6 window down. As Y6 open, a window will down. Allow the fixed components turn to the control system 1 for water cleaning. This I/O control is I/O control type 1 from the upper limit sensor positions as 19. As Y6 on, the window will down and down until reach window down sensor input 20 become 1. Then the window stop moving, sits there. As the Y6 off shut down, the window will started from window down sensor position as 20. The light will off and the window up and up until reach the window up sensor as 19, and the 19 become 1. Turn red, the moving will stop. This is on the I/O control. The motion in this machine controlled by I/O PLC, only 1 is Y6 in this example. Let's see the CSV file, how to write. From D drive CMS GAC data, let's search KH. KH33 PLC.CSV. Open it by Excel. You can see 2 stations. The first station continue column and in here. The second control system and in here. So the first control system, the second control system, with 2 control systems in this mechanism. The first control systems with 3 motion control. The first one is X-axis. The second is Y-axis. The third is Z-axis, while M2 is the foundation. And the 10 translocated 10, whatever, S pivot, Y pivot, Z pivot, N3 is define the viewport position. The first stations with tool. The tool defined translocate here is 3. And with 3 dummy, the object 5, 6, 7, we have to mention is translocate 4, 5, 6. 4 minus 3 is 1. 5 minus 3 is 2. That means this is 1. This is 2. 1 for what? 1 is this one. The first axis, the upper limit, the lower limit definition. The 2 for what? 2 for y-axis, the upper limit, positive 200, the lower limit, minus 500. The 6 minus 3 is 3. 3 is this one, the z-axis, the upper limit 100, the lower limit minus 200. The RGB arrows defined by the standard SORG, YORG, ZORG. And translocate state 99, 99. So SORG, YORG, ZORG, original locate at the center of Cartesian, according to the attached to number 3 z-axis, and the definition translocate 99. The system will locate at the tooltip TCP points automatically. As to the control system 2, started from this line. This line, the foundation with a dummy .x. Nothing will display on the screen. The first axis of the control system station 2 is C axis. The second axis is B axis. The third axis is A axis. The 3 axis O2 is rotation axis. Okay, down in here, you have to look careful. You can see here is 2, means this is I/O control object. The object number is 4. In here, 1 means I/O control type 1, linear control. From the upper limit position, move to the lower limit position. We already see the I/O tables, and we know the input 19 is the window up sensor input, PLC input number 19. And the input 20 is the window lower sensor PLC input number. The window movements by open Y6. As the Y6 on, the system will move linearly. According to the move values, we can know the X moving 0, the Y moving 0. The moving direction is Z-axis. Minus here means moving down 200 millimeters. There are 3 axes, so the 3 axis limitation divided in here. 4 minus 3 is 1. The first axis is C limit. The upper limit is 380. The lower limit is minus 33 80 degrees. The 5 minus 3 is 2. 2 is this one, is b-axis. The upper limit 380, the lower limit minus 380. This one is the third axis, A limitation. As to SORG, YORG, ZORG, we still have to write. But this is not the water tool or the cleaning tool. We don't need to display RGB here, so we mark 98. You can see it's different, the previous 99. To divide the TCP points RGB arrow. The 98 means this RGB, not the display. As a conclusions, if it's a mixture of I/O control and the motion control, the first station we have to arrange the motion control first. Of course, you can add the I/O control in the first control station as well. For each mechanism, we use one PLC. In the system, the PLC can be the maximum 256 input and 256 output. If without I/O control, that's fine, like this, the first control system without any I/O control. Then, if still with access, we arrange the control system too. In this case, if we have the I/O control, we can add anywhere, any objects as you wish, but you have to follow the specification. In this column, you have to write 2, means this object. Number 4 is I/O control object. And I/O control object, right now we define the type 1, type 2, and the type 3. So in here, mark 1 means I/O control type 1. Type 1, you have defined the upper limit input number and the lower sensor input number, and the accurate driven output number. The rest, N1, N2, and N3, defined if the N1 moving distance, write down in here. N1 means S moving distance. N3 means Y moving distance. N2 means Z moving distance, etc. You can write arbitrary as you wish, very free to write down the scene CSV table, while the control, the physical machines, the response encoder will let the virtual system immediately in real-time display the 3D geometry movements, while the I/O control will respond the input I/O, input output, triggered or not, and the model of the objects will automatically doing transformation inside the 3D acceleration car. We use the object arrangements. The objects can move linear or rotation, rotary. No scaling because the mechanism is fixed, not like a game, whatever's. Okay, so it's easy to use CMS CAPP to write down the cinema of any mechanism with I/O control as well as motion control, or only motion control, or only with I/O control, whatever you like. Let's run the system automatically as trigger input 1.
是妈妈说，吃完盆中餐，粒粒皆辛苦。直到最爱的裙子的扣子都系不上了，越吃得掉，甩不掉，更辛苦。希望体重重新拍打，帅哥，不如跟着节奏，没在怕的努力。别人